Okay, and welcome back to the Unit 2 review for astronomy. And now we want to go into lesson number 12, which is on planetary meteorology. So this is going to be found in chapter 7 of your textbook. And the first thing that you need to know is what are the atmospheres like of the various planets. Let's skip Mercury. So Mercury has such a thin atmosphere that let's not even worry about it. Mars and Venus have the same atmosphere. So both Mars and Venus have an atmosphere made of carbon dioxide. The only difference is in Venus it's very thick, and in Mars it's very thin. Earth has an atmosphere composed of oxygen and nitrogen. And then for the Jovian planets, so Jupiter, Saturn, Uranus, and Neptune, we're going to say hydrogen and helium. So those are going to be the atmospheres. Okay, then I just want you to see off this chart that without life, the primary component of our atmosphere would be carbon dioxide, just like Mars and Venus. So you should know what was the first atmosphere that the Earth had, and that was composed of hydrogen and helium, but it was lost very rapidly because they're very light gases. Okay, then the secondary atmosphere is going to be composed of water and carbon dioxide and other things that come out of volcanoes and also come from comets. Now, Earth is the only planet in our solar system that has a tertiary atmosphere. So this third atmosphere is going to be composed of oxygen and nitrogen. So you need to know what happened to the water that was in the Earth's atmosphere. So that became the oceans. You should know that what happened to the carbon dioxide. So that was turned into limestone. And then you should know where did Earth's oxygen come from. And so that's going to come from photosynthesis. Okay, the different layers of the Earth's atmosphere. So you should know about the troposphere and be able to tell me what happens in the troposphere. You should know about the stratosphere, what happens in the stratosphere, and then the ionosphere. So the ionosphere is not officially part of the atmosphere. It's actually when you combine several of the layers together. But you should know what the ionosphere is, what's going on up there, and what's causing it to happen up there. So if you go back in your notes and review what the ionosphere is. So there's the troposphere. Okay, stratosphere. So you should know about what ozone is. Be able to tell me that ozone is O3 and what you breathe is O2. And then what is it that destroys ozone? And then what are the consequences? So if the ozone layer is destroyed, what kind of consequences would it have on life on Earth? Okay, then you got the magnetosphere. So Earth's magnetism that extends into outer space. Why do we need the magnetosphere? So what does the magnetosphere protect us against? Okay, then we talked about how the Earth's atmosphere was heated. So this is going to be the greenhouse effect. Now we already talked about Venus, and it has the runaway greenhouse effect. But on Earth, the greenhouse effect is important because it helps to keep the planet warm. So make sure that you know what is the greenhouse effect, how does it work. Then the effect of water. So anytime that you've got a planet that has large bodies of water, that's going to moderate the climate, which means that during the winter time it's not going to be as cold, and then during the summertime it's not going to be as hot. Okay, how does a cloud form? So we're going to start off with moist air, and then that moist air, which is also warm, is going to start to rise into the air because it's less dense. Warm air expands and becomes less dense than the surrounding air, so it's going to float up until its temperature equalizes with the surrounding temperature, and then at that point the water vapor is going to condense into liquid water, and then you can see the cloud. You should know what pressure is. So pressure is going to be the weight or the force of all of the air molecules on top of us pushing down on a certain area. And that's going to be pressure. And so we're experiencing the weight of 6,200 miles of air on top of us. Okay, why is this important? Because whenever you have a low pressure system, that means air can rise. Low pressure means there's less pressure pushing down. So that means the air can rise, and then you can have clouds form. On the other hand, if you have high pressure, then the pressure is pushing down, and it won't allow the air to rise, and then you won't have clouds. Okay, let's take a break here, and then when we come back, we're going to continue talking about the Coriolis force.